You know that feeling, right? You're on a website during a huge sale, it crashes. Or an app goes viral and suddenly it's lagging like crazy. Well, that's a scalability problem. And today, we're going to dive into what it actually means for a system to be scalable and how engineers make sure services can handle massive growth without, breaking a sweat. Let's get into it. So, what is a scalable system? Really? Well, here's the textbook definition. It's basically a system that's built to handle more and more work. We're talking more users, more data, more requests, without slowing down or crashing. The whole point is to keep things running smoothly, with great response times and rock-solid reliability, even when things get really busy. But let's boil that down to its absolute core. If you remember one thing, it's this. Scalability just means the system can get bigger and still work great. That's it. It's really the difference between a system that thrives under pressure and one that just, crumbles.
All right, so we've got the what down, but how do you actually do it? How do you build a system that can scale? Well, it really boils down to two main paths you can take. You can either scale up or you can scale out. And here are those two approaches side by side. On one hand, you've got vertical scaling or scaling up. Think of it like upgrading your own computer. You're just making a single machine more powerful by adding more RAM or a faster CPU. On the other hand, you have horizontal scaling or scaling out. This is totally different. It's more like hiring a team. Instead of making one person stronger, you just add more people, or in our case, more machines, to help share the work.
So let's take a closer look at scaling up. A really common example is just taking a server and boosting its RAM from, say, 8 gigs to 32 gigs. It's straightforward, for sure. But here's the big catch. You will always, eventually, hit a hard physical limit. There's only so much power you can cram into one single box.
And that's where horizontal scaling really shines. See, instead of hitting a hardware wall, you just add another server to the group, then another, and another. This is exactly how the huge systems we all use every day, like Netflix or Google, work. It's way more flexible, and honestly, the ceiling for growth is practically limitless.
Okay, so you might be thinking, great, I'll just add a ton of machines. But hold on, it's not quite that simple. Just having more machines is only half the story. You have to intelligently manage all that new power, and that's where a few really key techniques come into play.
First up, we've got load balancing. The best way to think about this is to imagine a busy supermarket. If scaling out is like opening more checkout lanes, the load balancer is that helpful person at the front, directing people to the shortest line so no single cashier gets totally swamped.
Its main job is to act like a traffic cop for all the incoming requests. It stands in front of your group of servers and just spreads the work out evenly. This does two amazing things. First, it stops any one server from becoming a bottleneck, which keeps everything fast. And second, if one server happens to fail, no big deal. The load balancer just stops sending traffic there, and the system keeps on running.
All right, next technique. This one is all about handling huge, and I mean huge amounts of data. It's called data partitioning, or as you'll often hear it, sharding. Imagine your database is one giant, single-volume encyclopedia. As you add more and more information, finding anything becomes painfully slow. Sharding is like splitting that giant book into smaller, more manageable volumes like A through D, E through H, and so on. So by splitting that massive database into these little pieces, or shards, and putting them on different servers, the benefits are just huge. Looking up data is way faster because you only have to search through a small chunk of it. And even better, it lets you do what's called parallel processing, where you can have multiple servers working together on the same query at the same time. And that brings us to our final key technique, replication. Now, if sharding is all about speed and managing size, replication is all about safety and making sure your system doesn't go down. You can think of it like a really, really good insurance policy for your data. What replication does is actually pretty simple. It just keeps multiple identical copies of your data on totally separate machines. So if your main server suddenly fails, maybe a power outage or a hard drive dies, the system can instantly and automatically switch over to one of the healthy copies. The user never even knows anything went wrong. This is absolutely crucial for high availability and fault tolerance. So there you have it. From that first big choice, do you scale up or scale out, to the essential techniques of load balancing, sharding, and replication, these are the real building blocks. This is how you create systems that don't just survive when they grow, they actually thrive on it. These are the ideas that let a small startup become a global giant, which really just leaves one question. Now that you have these tools, what will you build?